This is the Taylor series expansion formula, and we want to find a Taylor series expansion for the function f of x equal to sine of x. So what we need to do is find the first few derivatives and then see if we can find a formula, a pattern. And so f of x is sine of x. And so we'll find the first 6 derivatives and then evaluate the derivatives at x equal to 0. The derivative of sine of x, first derivative is cosine of x. And then the second derivative cosine of x is negative sine of x. The third derivative, the derivative of negative sine of x is negative cosine of x. The fourth derivative is sine of x. And then the fifth derivative is cosine of x. And then the sixth derivative is negative sine of x. And so now we got the first six derivatives, and we evaluate each derivative at c equal to 0. And so first f of c or f of 0, which is 0. And then first derivative at c would be cosine of 0, which is 1. And then second derivative at c, which is negative sine of 0, which is 1. Third derivative at c is negative cosine of 0, which is negative 1. Fourth derivative at c is sine of 0, which is 1. And then fifth derivative is cosine of 0, which is 1. Sixth derivative is negative sine of 0, which is 0. So we can see the pattern here is going to be 0, 1, 0, negative 1, 0, 1, 0, negative 1, and so on. And to get the Taylor series expansion, so in the place of f of c, we have 0. In the place of f prime of c, we get 1. And then in the place of c, we just have 0. And then in the place of the second derivative at c, we get 0. And for the third derivative at c, we get negative 1. And then the fourth derivative, we get 0. The fifth derivative, we get 1. And then the sixth derivative, we get 0. And so again, f of c is 0. F prime of c is 1. And then the second derivative is 0. The third derivative at c is negative 1. The fourth derivative at c is 0. The fifth derivative at c is 1. And then the sixth derivative at c is 0. And so all the even powers will get 0. And so we only get the odd powers. So here we get x to the first. And this is minus x to the third, dividing by 3 factorial. And then this would be x to the fifth, dividing by 5 factorial. And the next we get negative 7, negative x to the 7, dividing by 7 factorial. So it's going to be positive, negative, and then the rest of it. And so what we do is we look at this pattern here, and then we will see that the nth term for this pattern is going to be negative 1 to the n, x to the 2n plus 1, dividing by 2n plus 1 factorial. And so in terms of summation, would be the infinite series from 0 to infinity of negative 1 to the n, x to the 2n plus 1, dividing by 2n plus 1 factorial. And then we can check this summation formula right here. So when n is 0, then we get negative 1 to the 0, and then this will be 2 times 0 plus 1 is 1, and this is 2 times 0 plus 1 is 1. And so we get negative 1 to the 0 is x, and then negative 1 to the 0 is 1, and 1 factorial is 1, so we end up with just x. And when n is 1, then we get 1 for the exponent here, and then 2 times 1 plus 1 is 3, and then 2 times 1 plus 1 is 3. So we get negative x to the third dividing by 3 factorial. And then when n is 2, we get a negative 1 to the second, and then this will be 5, so it will be x to the fifth, and dividing by 5 factorial. And so negative 1 to the second is positive 1, so we get x to the fifth dividing by 5 factorial. So these are the first 3 terms of the expansion right here. So it's x minus x to the third dividing by 3 factorial, x to the fifth. So we know that this nth term formula works. And therefore this is called the Taylor series expansion for sine of x. So sine of x is equal to x minus x to the third dividing by 3 factorial plus x to the fifth dividing by 5 factorial, and so on. And this power series converges for all x from negative infinity to positive infinity.